All right, so this is going to be the back of your formula chart in 5.3, and we start with odd and even functions, and this is on your formula chart as well. But to be an even function means that it is symmetric about the y-axis. So if we think about the two trigs that are symmetric about the y-axis, that's going to be cosine. And if cosine is symmetric about the y-axis, then so is secant, because secant was the two, or the u's that go on top of the cosine graph. So even functions means it's symmetric about the y-axis. So even though that's not what this says, if you think about what this says, it's saying f of negative x is equal to f of positive x. So what that says is that if you take any x value, if you take this x value, you would come down here to this y value. Well, using that same x value, but the negative version of it, you would still land on that same y value spot. So that's what this sentence says, and that's why it's an even function. This symmetry only happens, f of x is equal to f of negative x, only happens if it's symmetric about the y-axis. So our two even functions are cosine and secant. And so everything else is what an odd function is. So the odd functions are sine, cosecant, tangent, and cotangent. All right, let's talk about cofunction. Now, cofunction, if you've ever wondered, we've been studying pre-cal now for 3 months. If you've ever wondered what the relationship between sine and cosine is, we haven't really talked about that much, but this is where it comes into play. Let me go back to how you first were introduced to trig. How you were first introduced to trig is if you have a right triangle whose vertex B is at the right angle, then 7 is the hypotenuse. Then when you were first introduced to trig, your geometry teacher would say, okay, let's solve for, let's say, angle A. And so you would say sine of angle A is equal to opposite over hypotenuse, 2 over 7. Well, let's say instead of solving for angle A first, you solve for angle C. So if you did angle C, well, now you can't do opposite, right? Because you don't have the opposite side. You'd have to do cosine of angle C, but that would still equal 2 over 7, adjacent over hypotenuse. Well, they're both 2/7, but are angle A and angle C going to be the same angle? And the answer to that is of course not. They're actually going to be complementary of each other, because if this was, say you did this math and you ended up with 20 degrees. I don't really know what it is. I'm just saying for an example. If this is 20 degrees, then this would have to be 70 degrees because the angles of a triangle have to add up to 180. And so their complements are 20 and 70 because they add up to 90 degrees. That's what complementary angles are when you're talking about sine versus cosine. So those are complement angles. So if you look on your formula chart, all of this is written down for you. It's under the complement or cofunction section, but the co in cofunction stands for complement. So you identify what the complement is, so 90 minus is the complement, and then use the cofunction. So for example, sine of 36 is equal to cosine of 54. Now this is a non-calculator section. However, that being said, I think it's a great idea for you to check this out on your calculator. If you type in sine of 36 degrees, make sure that you're in degree mode for this, but if you type in sine of 36 degrees, you get 0.5877, so forth. Now, if you type in cosine of 54 degrees, you get that exact same 0.5877, etc. That's because they are cofunctions of each other. So, if we do the rest of these cofunctions, sine of 20, well, the cofunction of sine is cosine, but if you're going to do cofunction, then you don't use 20 anymore, you use 90 minus 20, which is 70. Okay? The cofunction of tangent is cotangent. The cofunction of secant is cosecant. Okay? All right, so this is just the rest of that. This is on your formula chart. On your formula chart, it only gives you the radians, but we know that pi over 2 means 90, so it's the same thing. All right, in example 1 and 2, this is just some practice. So cosecant of 35 is what? So cosecant is the cofunction of cosecant is secant, and then 90 minus 35 is 55. Okay, if you do it for tangent, tangent's cofunction is cotangent, and 90 minus 15 is 75. All right, let's go on to slide 2. All right, so now we're on to sum and difference. This is the third section of the back of your formula chart. So the sum and difference is cosine of A plus B compared to cosine of A plus cosine of B. What I'm trying to show you here by showing that they are not equal to, make sure that you're reading the not equal to, but what I'm trying to show you here is that trig absolutely, without exception, does not distribute. So, of course, what I mean by distribute is a lot of people are tempted when they look at this statement to say cosine of A plus cosine of B, and that's how they're getting this. That is absolutely not a true statement. So I'm going to erase that because I don't want you to look at that. But that's what I'm saying you should not do. So I'm going to prove that this is in fact an untrue statement by evaluating cosine of A plus B and evaluating cosine of A plus cosine of B and showing that they are not equal to each other. And we're going to say A is 30 degrees and B is 90 degrees. So cosine of A plus B, and A is 30 and B is 90. So cosine of 30 plus 90, well 30 plus 90 is 120. And we know how to evaluate cosine of 120 degrees. This is 120 degrees, but that means that my reference angle is 60. So across the 60 is root 3. Across the 30 is 1, and across the 90 is 2. And this is going to be a negative 1 because it is going left. So cosine of 120 degrees is equal to negative 1/2. So again, what I'm trying to do is compare that to cosine of A plus cosine of B. So remember that A is 30 and B is 90, so I'm going to evaluate cosine of 30 plus cosine of 90. And I'm trying to show that it is not going to be equal to this negative 1/2. Well, cosine of 30 degrees is equal to root 3 over 2. And cosine of 90 degrees is right here. The adjacent of that is 0. And root 3 over 2 plus 0 is root 3 over 2. And so now if you notice, what I'm doing is I'm going to compare this compared to this, and they are in fact not equal, which is exactly what I was trying to do. So instead, what we do when we see sum and difference is we look on your formula chart and we use these rules for the sum and difference. So I want you all to look at the formula chart. Try to identify where cosine of 34 times cosine of 20 plus sine of 34 times sine of 20 is. And let me rephrase that. You're not going to find the 34 and the 20, but you're going to find cosine of something times cosine of something different plus sine of something, sine of something. So if you match that up, so go ahead and pause it if you want to match it up. But what you should match that to is you see on your formula chart where it says cosine, and I'm just going to write it right underneath, of A times cosine of B plus sine of A times sine of B. And that's equal to, if you look on the other side, cosine of A minus b. So we can simplify all of this to cosine of a minus b, where the formula chart is matching up. 34 is going to be our a value and 20 is our b value. So that's going to be cosine of, so again, 34 is a and 20 is b. And 34 minus 20 is 14. So let me iterate this again. This is a non-calculator section. So you don't actually get the answer to this. You're just saying what this is equivalent to, or a simplified version. These two things are the same or equivalent to each other. Now, even though this is non-calculator, it's still sometimes kind of fun to look these things up on your calculator just to make sure that we got it right. So if you typed in to your calculator this big long expression, so I just did that and I got 0.970. And then if you type in cosine of 14, you should get that exact same 0.970. So they are equivalent to one another. So it's a good idea to check on your calculator. Just be prepared for a non-calculator test. All right, so we do have proofs in this unit. So the proofs in this unit I think are a little bit easier because it's very clear as to what you should do. And what we do is we use our sum and difference to kind of match up to what we have. You still are going to pick only one side to start with, so let me rewrite this sign. So cosine of x minus pi. And if you look on your formula chart where you have cosine of something minus something. So cosine of, in that case on the formula chart it says a minus b. And that is equal to, so in red right here, this is me just going to write out the formula chart because I think it's extremely helpful to do this so that you can kind of just match up. You know, a is x and b is pi. So when we write that out, I'm going to write that out in red. The formula chart tells me do cosine of a times cosine of b plus, so I'm using the formula chart right now, sine of a times sine of b. Okay, so now my actual proof is this guy. This isn't a proof. This is just me kind of realizing what I'm going to have to do. So my proof is use x for a and pi for b. So cosine of, and instead of a, I'm going to write x, times cosine, and b is pi, plus sine of x times sine of pi. All right, my next step, so only be focused on this. This red, this handwriting in red was just to kind of help you get to here. Now, my next step is going to evaluate what I know. So, what can you evaluate with this that you've wrote down? Well, if you don't know what x is, you don't know how to evaluate x. But I do know what pi is. Pi is like 180 degrees. Therefore, I can evaluate cosine of pi. That same reasoning, I can evaluate sine of pi. So let's draw pi. This is pi. And if you need a quick reminder, when you land on an axis, your opposite and your adjacent, opposite is like your up to down, so that's 0. My adjacent is backwards, so -1, and my hypotenuse is always 1 on an axis. All right, so that's just a quick reminder so that when I do this next step, I can go through it. All right, so once again, I'm using this. I'm going to evaluate cosine of pi, and I'm going to evaluate sine of pi. So cosine x, I don't have any way to evaluate that because I don't know what x is. So I'm just going to rewrite cosine x times. Now, cosine of pi, I know is equal to adjacent over hypotenuse of the pi. So the adjacent is -1, the hypotenuse is 1. So -1 over 1 is -1. Now sine of x, again, there's no way to evaluate if I don't know what x is. But sine of pi, I do know how to evaluate. So again, I look at pi. I say, well, here's where pi is. Sine of an angle is equal to opposite over hypotenuse. So 0 over 1, which is 0. All right, so now what is sine of x times 0? So that's 0. That goes away. What is cosine of x times -1? Well, that's equal to negative cosine x. Okay. All right, in example 6, if you look at example 6, this is cosecant of theta minus 90. Something interesting is that on your formula chart, you actually don't have any of the reciprocals. You're only given sine of a plus b, sine of a minus b, cosine of a plus b, cosine of a minus b, tangent of a plus b, and tangent of a minus b. So what we have to do is use reciprocals. So let's start on that side. Now, don't get reciprocals and cofunctions confused. Reciprocals was the whole 1 over. Cosecant's reciprocal is sine. So I'm going to rewrite this as 1 over sine theta minus 90. I don't know why I'm writing so big, because I need more space than that. So I'm just going to have to... Okay. So now this is something that I can spread apart using sum and difference rules. So go to your sine a minus b, and again, I just like to write it right underneath so I can kind of see what I'm going to fill in. So this tells you it's sine a cosine b. I should make sure I'm doing this right. I think I have them memorized, but I don't know for sure. By the way, you would never have to memorize this. I've just done this too many times. So sine A cosine B minus cosine A sine B. Let me scoot over. All right, so now I'm going to fill it in with A being theta and B being 90. A common mistake I see, don't use negative 90. This is a minus sign that told us to go to A minus B. You've already kind of, everything goes to each other. Theta is A, minus is minus, 90 is B. Okay, so don't do negatives at all. The negative is already accounted for. All right. I'm going to do this in red. So sine, and instead of A, I have theta. Cosine, instead of B, I have 90. Cosine, that's a minus. Theta times sine 90. All right, if we evaluate what we know how to evaluate with the 90 degree. So if you want to write this down, your opposite is 1. Your adjacent is 0, and your hypotenuse is 1. I'm just going to have to, hypotenuse is 1. All right, so sine theta. I don't know what theta is. I can't evaluate sine of theta. Therefore, I will rewrite sine of theta. But the next thing, cosine of 90, I know how to evaluate that. I go to the 90 degree. Cosine is adjacent over hypotenuse. So 0 over 1, which is 0. Okay, now I have my minus sign. Cosine of theta. once again, I don't know what theta is, so I'm just going to have to write cosine of theta. But sine of 90, I can evaluate. Sine of an angle is equal to opposite, which is 1, over hypotenuse, which is 1. So that's 1. Once again, when you multiply times 0, it just makes it go away. Multiplying times 1 isn't going to change anything. So I have 1 over negative cosine theta. And if I asked you what 1 over cosine was, you'd say, well, that's secant. So 1 over negative cosine is negative secant, which is exactly where we were trying to go. And that's it for today's notes. Hopefully you think these proofs are a little bit easier because there's not really much question as to what you do. You look at what it looks like, you go to the sum and difference, you evaluate using the sum and difference. You evaluate what you can, you fill in the blanks, you simplify. So that's it for today's proofs.